All right, welcome to calculus today, pre-calculus today. We're going to look at terminology and notation of vectors, and we are also going to do a little bit of finding components of a vector and finding magnitude. So that's what we're doing today. This is basically Unit 4, Topic 1, Part 1. So these are the two objectives: using terminology and notation and writing vectors in component form. We have a warm-up, some vocabulary, some guided practice, and a check for understanding. This week's homework and formative are published, and then don't forget about week 10, the week 10 work that we assigned last week that's due on Wednesday, April 21st. So don't forget about that. That's the first marking period grade of marking period 4. All right, so for your warm-up, what is the difference between these two statements? Jose lives 3 miles west of Annie. Jose lives 3 miles away from Annie. Just take a moment to think about that. All right, so the difference is west provides a specific direction, whereas away is just a distance. So if you live 3 miles west of somebody, you know exactly where to go to find them. 3 miles away could be anywhere in a radius, a 3-mile radius, but west is actually, there's only one place you can go. And that's what we get to when we're talking about vectors. Vectors are quantities with both magnitude, like a distance, a length basically that can imply like their direction, or not their direction, their force. And it also has direction, which means that we know exactly where to locate it on a coordinate plane. Some vocabulary that goes along with vectors: we have magnitude, which is the length of a directed line segment; direction, which is the directed angle between the positive x-axis and the vector; standard position, which is a vector that has its initial point at the origin. And that's pretty much what we're going to be working with today. Okay, this is what a vector could look like. You see it has a direction, it has a head, a tail. The magnitude is really calculated by the length of it, and then the direction is, again, the angle from the x-axis, the positive direction, to the vector. So you can see that some of our trig is going to come, you can anticipate that some of our trig is going to come back in handy here. All right. Some other vocabulary that we're not going to use a ton of, but just so you know in case you can't come across it: a zero vector is a point or vector with no magnitude. Equal vectors have the same magnitude and direction. Opposite vectors have the same magnitude but opposite direction. Parallel vectors have opposite direction. Perpendicular are vectors with 90-degree difference in direction. And then lastly, this is what we're going to work on a little bit today. Scalar quantity is magnitude with no direction. And then horizontal and vertical components are basically the legs of the right triangle. So this visual here is really what is helpful when we think about it. We have this vector, vector A, right? It has a tail at the origin, and then here is its head right here. And then you can find the horizontal component by finding this leg of the triangle, the horizontal leg of the triangle. And then the vertical component is the vertical leg of the triangle, okay? And the way we can calculate it, the formula is here is a sine theta for the height or the vertical component, and then a cosine theta for the base or the width, which is the horizontal component, which makes sense, right? Because if you think about this, let's say this is our, we'll just call this x and y. It makes sense when you think about trig. The sine of theta, being opposite over hypotenuse, would be y over a. Cosine of theta would be x over a. So a sine theta would be y, because that's basically multiplying both sides of your equation by a. And a cosine of theta would be x, because multiplying both sides of your equation by x. All right, so we're going to try it here. I'll just do an example. Here's a leash, a vector force of a person pulling this poor little dog on a leash. The magnitude of the force is 60, okay? What is the vertical component of the force and the horizontal component of the force? All right, so the vertical component is written over here. The horizontal component is written over here. I don't know if you can see my mouse with this recording, but we'll just go ahead and do it. So the horizontal component would be 60 cosine of 40 degrees, which you can see here is 45.9. Okay. And N stands for newtons, by the way. It's N represents newtons, which is a unit of force. Okay, and then the vertical component, you can see it's written over here. The vertical component would be 60 sine of 40, which ends up being 38.6. Okay. So this is, and now we're going to come into another part of the vector vocabulary, which is writing in component form. So the horizontal component, we write the vector with the horizontal component, comma, vertical component. Just like we might write a point x, y, we write a vector horizontal, comma, vertical. So horizontal would be 45.9, comma, 38.6. Okay, because we're saying, okay, it's from the origin, our horizontal component is 45.9, vertical is 38.6. If we were to graph it on a coordinate plane, that's where we would graph it, at the point 45.9, 38.6. So it's kind of like your x and your y. Okay. All right, now you can try it. Go ahead and pause the video, give it a whirl. Okay, so hopefully you've tried it. So you want to make sure that you're in degree mode when you do this. So if you are using, let's say you're using Desmos Scientific Calculator, you want to make sure you're in degree mode. All right, so we have this vector. It is 15, the magnitude is 15, and the direction is 60. So let's say we make these little right triangles, and your horizontal component would be 15 cosine of 60, which is 15 cosine 60, 7.5. So we have 7.5 miles. Right? Vertical component would be 15 sine 60, which would be 15 sine 60, which is 12.990 miles. 12.990 miles. 12.990 miles. So if we were to write the vector in component form, that would be 7.5, 12.990. Okay. And then the last two pieces I want to leave you with today are finding the magnitude and direction of a vector. So the magnitude really just stems from the Pythagorean theorem, right? If this vector is, the components are, we go from 0 to 2, and so the horizontal component is 2, and then we go from 2 to 3, so the vertical component is 3. The magnitude is just basically the Pythagorean theorem, or the distance formula, which is derived from the Pythagorean theorem. So 3 squared plus 2 squared equals the magnitude squared, which we can call, whatever we want. But so that's kind of how we're going to find it. Okay, so we can go to our calculator and hit square root of 3 squared plus 2 squared, and we get 3.606. So I'm just going to round to 3 decimal places. 3.606. Okay, so that's how we would find the magnitude. If the vector started at a different point, let's say your vector started at 1, 1 and ended at 2, 3, obviously you'd have to do the distance formula there, right? Because you know that the distance between 1 and 2 was 1, the distance between 3 and 1 is 2. So in that case, you'd actually want to go full on with the distance formula. So you'd have to do 2 minus 1 squared plus 3 minus 1 squared, and then square root that sum, right? So that would be, if you didn't start at the origin, that would be where your vectors where you'd have to calculate the distance formula, okay? And then the last thing is direction. So direction is the angle. Direction is the angle, okay? So the best way to find it is if you have the horizontal and vertical components, you can just use, because this is opposite over adjacent, your angle's here, this is opposite over adjacent. So the tangent of your angle has to be 3 over 2, right? So to solve, you'd say inverse, right? Inverse tan of your of this ratio. So then your angle would just be whatever that is. Your angle would be inverse tan of 3/2. So let's find that. So let's do a function inverse tan of 3/2, 56.3099, so 56.310. 56.310 is the angle. So anytime we want to find the direction, a good formula to go by is inverse tan of the vertical component over the horizontal component, because it's opposite over adjacent. Okay. All right. Now this one is suspicious. Go ahead and give this one a try and see if you notice anything suspicious when you calculate the direction. And give it a try and then resume the video when you're ready. Okay, so hopefully you've discovered by now that there's kind of a problem with the direction. So if we use just the inverse tan process, we get negative, your angle is negative 50.194. And that doesn't seem right, because if you have an angle of negative 50, that's going to be here, right? That's going to give you a vector in the fourth quadrant. And that's actually not what we want, okay? So here's your tip. If you get an angle in the wrong quadrant by using inverse tan, you just need to add 180. So this is related to the fact that inverse tan, the domain is restricted to negative pi/2, pi/2. So if you remember that from our unit 3 topic 2 learning, that's kind of like, you know, it's just your tangent range is just restricted to this half of the coordinate plane. So if you get a goofy angle, you just need to add 180 to that. So we'll just take that answer plus 180, and that should give us the correct angle, which is 129.806. Plus 180 is 129.806. Okay, all right. So let's pull it all together. So we've learned 4 things today. We've learned vocabulary of vectors. We've learned component forms of vectors, magnitude, and direction. So go ahead and put this all together. Pause the video, give it a try, and then we'll go over it. All right, so hopefully you've paused the video and tried the problem. Okay, so for writing this vector in component form, we'd have your x component of your vector would be 27 cosine of 55. And your y component would be 27 sine of 55. So let's do that. 27 cos 55 is 15.487. 15.487. Let me make that clear that that's a 4. .487, and then 27 sine of 55. 27 sine 55 is 22.117. 22.117. Did I write that correctly? Yeah, okay. So to write it in component form, it's XY, so 15.487, 22.117. And that's number 1 checked off. Okay, now find the magnitude of the vector in direction of the vector below. Remember to check your angle. Okay, so we've got a vector. Here's our XY coordinate plane, and it's at 8, -5. So 8, -5. So our vector is right here. All right, so the magnitude should be square root of 8 minus 0, but I'm just going to leave it as 8 squared plus square root negative, or quantity -5 squared. So let's see what that is for magnitude. Square root of 8 squared plus 5 squared. I'm not putting the negative because the negative is eventually going to not matter, right? So I could just put, I could do it like that, but it'll still be the same answer. So we end up getting 9.434. 9.434 is the magnitude. All right, and let's do the direction. So direction would be inverse tangent -5/8. So inverse tangent -5/8. Oop, I wrote 7. Okay, -5/8, and that's -32.005. -32.005. Okay. And that actually tracks because -32.005 is in quadrant 4, and so is this vector. So I don't need to add 180, okay? If you wanted to write the angle in standard position, you could just add 360 to it. So if I added 360, that would give me 327.995, and that would be the angle in standard position. If I didn't want to write a negative angle, and I just wanted to write it on that 0 to 360 domain, or not domain, the 1 rotation around the unit circle, 0 to 2 pi or 0 to 360, I could write it this way, 27.995. 0.995 degrees. All right. So that's fine. All right. So to recap, we've done component form using magnitude, sine, direction, magnitude, cosine, direction to find components. And we've also found the magnitude and direction of vectors. What we're going to work on tomorrow is adding and subtracting vectors and using some scalar multiples. So, but for today, this is really what the expectation is, that you know how to do all of these 4 things. All right, so for your check for understanding, which one, multiple choice, which one of the vectors below could have a magnitude of 5 and a direction of 126.870 degrees? Circle the correct answer and sketch the vector on the graph. All right, thanks for watching. Hope you have a great rest of your day.